Okay, let me give you guys a Calculus 1 optimization problem. So here you've got a circle of radius 10, and your job is to find a value of x for which it will give me the biggest area of this rectangle. Okay, so let me illustrate. Your job is to find a value of x for which it will give me the biggest area of the rectangle. So as you slide x back and forth, your job is to optimize or find the biggest area of the rectangle. So when x is 1, you can see that the rectangle is quite small. As you increase, it will get bigger and bigger and bigger and bigger, and then smaller and smaller, and then smaller and smaller, and so on. So find the value of x for which it will give me the biggest area. So press pause and have a go. Okay, so to do this, let's try and understand the problem first. So let's just imagine it's currently at 6. So this must be -6. So what is the area? So your job is really to find a function of x, find the area as a function of x. So if I put a 6 into the machine, it will somehow work out the area. So this length must be 12, and then the height. Well, if you want to know the height for a given x, put 6 into the x. Put 6 into the x and then work backwards to find y. That will then give you the height. Y represents a height. So here y would be this, hang on, 100 take away 36 and then square root both sides. So y would be this thing here would be 64 and then square root it, that would be 8. So here the height, not to scale, is 8. So if you know the height is 8, then you can work out the area. So it would be 12 times 8. So your job is to find the area as a function of x. So for any given value of x, what is this area here? So the area would be, well, what is this whole length here? This whole length here would be 2x. Would be 2x. What is this height here? Well, if you want to know the height, then make y the subject. So here, make y the subject. That would be you square rooting both sides. So when you square root both sides, y equals. When you square root both sides, you will get the positive version and the negative version. Well, the positive version is this strand. The negative version would be this strand. We don't really care about the negative strand, so ignore the negative. So really y, the height, is given by this. So let's start again. If you want to know the function for the area for any given x, all you have to do is get this length, which is 2x, and then times by the height. The height there would be, we worked it out earlier, it was 100 take away x squared. So here you've got a function. For any given value of x, you will know the area. So, hang on. So if you punch this into a graphical calculator, it will give you this graph, not to scale. And your job is to find, well, your job is to maximize the area, because this is an area versus x. For any given value of x, you have the ability to work out the area, and you want to find the biggest area, which is this point here. So if you want to find this point, you've got to ask yourself, what's so special about this point, the highest point? Well, at the highest point, the gradient would be 0. So you need to differentiate this thing here. You need to differentiate it. That will then give you your dA by dx, and you want to find out when the gradient will be 0, and then you set it to 0. So, for example, currently we are here. We've got an area as a function of x. So let me rewrite this block as to the power of a half. So now I need to find where the gradient would be 0, meaning I need to know I need to differentiate it. So find dA by dx. So differentiating this would then give you this thing here. So let me show you how to differentiate this. Hang on. So to differentiate this, you've got one block times another block. So you've got to use this block here contains a variable, this block here contains a variable. So you know you have to use the product rule. So the product rule is differentiate the first, leave the second alone, and then plus leave the first alone, differentiate the second. So let's try and do it. So hang on. So the product rule is differentiate the first, which will then give you 2. Differentiate the first, leave the second alone, which is this thing here, and then plus leave the first alone. This is us using the product rule, and then differentiate the second. Differentiating the second would be this power moves down here, the bubble stays the same, the power gets minused by 1, and then you've got to times the derivative of the bubble itself. Well, the derivative of this bubble is this thing here. So the 2 comes down, the x stays the same, the power gets minused by 1. So, well, anyway, think about it. When you differentiate this, it will then give you this thing here. So now tidy this up. This 2 will get cancelled out with this 2 here, which will then give you x. And then this block here, you've got this block times this block. Well, for this block, you don't understand what it means to have a power of a negative. So you immediately jump to, so just this block here, you immediately jump to this thing here, 100 minus x squared to the power of the positive version. But then to the power of a half, it's really this square root. So this thing here will then become this. And then leave this alone for the time being. So that will then take us to here. So now you've got 3 blocks, 1, 2, 3. This gets multiplied to the top, this gets multiplied to the top, and then drag out the negative here. So that will then give us this thing here. And remember, we want to find out when the gradient, we want to find out the highest point. The highest point of the gradient would be 0. So once we've got dA by dx, put 0. So currently we've got this thing here, a equals this. When you differentiate it, it will give you this. So we want to find the highest point. At the highest point, dA by dx would be 0 because the gradient would be 0. So put 0 into here. Put 0 into here. That will then give you this thing here. So now try to find a value of x for which this side equals 0. So now you've got 3 blocks, 1, 2, 3. Add this block to both sides. That will then give you this thing here. And see this block here. This block here is exactly the same as this block here. So in your mind, times both sides by this block. So this whole thing here will then give you this. And then this thing here will then give you this. Because if you think about it, when you times this by the exact same thing, this block here times this block here, that's exactly the same as me doing this thing here squared, which when you square a square root, it disappears, leaving you with this. Well, think about it. From here, it will then take you to here. So now, cancel out the 2. That will then give you this. That will then give you this, and then add x squared to both sides. That will then give you this. Divide both sides by 2. That will then give you this. Square root it. It will give you the positive version and the negative version. We don't really care about the negative version. We only care about the positive version. So ignore the negative. So here, the answer is x equals square root of 50, which, remember, 7 times 7 is 49. So it's slightly above 7. So what that means is slightly above 7, it will give you the biggest area. So what that means is at root 50, it will be the highest point where dA by dx equals 0. The gradient would be 0 at the highest point. And if you want to know the area, remember earlier we had a formula for the area. The area as a function of x is given by this. So if you want to know the area, what you do is you put 50, root 50 into the function, and then that will then give you this thing here. So the area would be 100. So overall, the value of x, which would give you the biggest rectangle, the value of x which would give you the biggest rectangle would be 50, would be root 50, and then the area will be, the area of the rectangle will be 100. Okay.